So in this video, we are working on the question number 2. So in question number 1, I did a breakout into the small modules so that you are able to read through, kind of watch a short video to learn each concept. But in this video, we're actually going to solve the question number 2 as integrated case so that the video itself will be maybe a little bit longer, but it's allow you to see how we can use in the method we learn in the class to solve an integrated case. Okay, so question number 2, the data we're looking at is the average hourly megawatts of electricity used in New York City for the year 1993 through 2004. So first of all, we want to plot the series and explain what can we learn from this plot. So basically, since it's just one column, it will be a time series data, and we want to see, are we seeing any trend? Are we seeing any seasonality? And then question number B, calculate the first 24 autocorrelation for the series and explain what characteristics of the data are shown in the ACF and PACF. So basically, question number 2, we're going to leveraging our ACF and PACF diagram to see are we see any spike. The spike are indicating the type of the ARIM model we're going to use. And number C is suggest and estimate an optimal ARIMA model. So based on the question number B, we are able to have a guess on what the ARIMA model should look like. But eventually, we want to use the ForecastX actually help us to identify the best value for P, D, and the Q, right? And also, if we have a seasonality, we need to make sure the ForecastX also can capture that as well. Then question number D, estimate the ARIMA model that you believe to be a good candidate for forecasting electricity use. And we are doing the test, Lin-Jon box test, to assure the model we adopt will leading us to the model that only give after we use the model to estimating our time series data, the residual itself will just become white noise, right? So therefore, we are testing out this Lin-Jon box test to see that. And then finally, we will do a 24 autocorrelation of the plot for the residuals. So that's the second way to do the diagnostic to assure the ARIMA model we achieved here is the best model we're looking for. Okay, so after we go through this case, we can start to work on Excel to solve this problem. Okay, so let's look at the data, and we're going to look at the second tab. Okay. So not surprising, this is the data. We're going to select the data. So the good thing is the data does have the first column as the frequency of the data. Okay, let me just select it. It is many rows. So we have 144 rows, 444 row of data. So after you select the data, click it in, add ins, and then we're going to click forecast. Okay. So after you click forecast, like I said, the good thing when you have the data set, including the data column, the date column, is they already set up the data capture column correctly. So we have the columns, the first row is labels, and then so since the data only showing as the monthly data, so that's monthly data. Okay, and then let me go back to the question one more time. Okay, so it doesn't say how far in advance we want to predict, so that's okay. And then we want to come back. Let's just forecasting for, since it's monthly, I want to do 12. So we want predicting the next year, okay? So after we do that, we are going to the forecast method. We will choose Box-Jenkins method. And then at this point, for the first question, we want to identify our ACF and the PACF diagram. So to do that, we need to click the analyze. Again, by default, the bar we see here is only 12, but the problem we are facing here is they want us to generating 24 autocorrelations. Okay, 24 autocorrelations. So then we need to increase this to 24. Okay. We can click OK, and then we do it again, click Analyze. So now we see 24. Okay, under the 24, so this is under 24. As you can see in our diagram for the ACF and PACF we can very quickly see there is seasonal patterns, right? We have many spikes under the ACF, and basically the ACF diagram is not dying down. Remember, if the data is stationary, so the ACF diagram and also PACF diagram, especially ACF, will very quickly to dying down to 0. But as we can see here for the ACF diagram, it doesn't die down. So it just alternatively go up and down and go out of my 95% confidence interval. So we have so many spike under the ACF, and also we have so many spike under the PACF. So the data itself might potentially have the seasonality problem. So to confirm this belief, we can go back to look at our data again. So that's actually the first question number A asks us to do is do a plot. Okay, let me select my data. So after I do that, I would say insert, and I would choose my line chart. I would choose the first line. Okay, so as you can see, it's not surprising. There is a slightly upward trend, but we definitely can see the seasonality. So if you think about our electricity usage, it's not surprising, right? So in the winter, we tend to use more electricity than the summer because you went outside more than in the winter, you more likely stay at home, need electricity to heat up your house. So you are able to see this kind of seasonality. So therefore, it's not surprising as we are doing diagnostic for ACF to PACF diagram, we see that seasonality, okay? So after you're developing this diagram, so you can save it by clicking export. So it will creating a new sheet for you so that you can save it, okay? And then if we go back to my diagram again, so here I will click OK. Great. So now what we're gonna do is after we are able to solve the problem number A, creating the diagram and creating the ACF and then PACF, identify the pattern. So the next is we're gonna using our ForecastX model to give us the suggestion what is the best optimal ARIMA model. Okay, so let's do it together. Let's go back to my data. Okay, so after you finish the second tab, we don't need to do any changes. We don't need to fill in any value under the parameters. The reason is because the computer will automatically choose the parameter that give us the optimal outcomes. So now we're going to move on to the statistics. Okay, so for the statistics, make sure you have your everything checked here. In order to get in the Q statistics that is used to do the diagnostics, you need to make sure you click the more statistics. Okay, so here I use 12, but as you can see based on the data, we did see the seasonality. And then it's not even so if you see the seasonality, it's annually. So the monthly seasonality. So as we learn from the textbook, if we have seasonality, so the Linjang box text, instead of using the default 12, we should use 4 times the seasonalities. So since the seasonality here is 12, so 4 times 12, it will give us 48. So we will change this to 48. Again, if the data you're dealing with has no seasonality, feel free to just go ahead and use 12. But if the data do have seasonality, you need to make sure change it here to the 4 times the periodical, how long the seasonality lasts, right? So it's 12 months. So here it will be 4 times 12, 48. So after you do that, and you can click OK. And also don't forget to check the box RMS. So that's RMSE. So some of the question you work on homework may ask you to calculate RMSE. So you don't need to calculate because the ForecastX already gonna report it to you. Okay, after you do that, we can click OK. Great. And then so for DW statistics, since we do have the seasonality, feel free to change this to 12 as well. And now we are going to the report. So on the report, we are using the auto report, and make sure you check the box, fit the value table, and then after that, when we click finished. Great. So this is my forecasted result, and I forecast the next year. And then if we are scrolling down, let's see the best model our ForecastX picked. Okay, so the best model our ForecastX picked, let me zoom in a little bit so you can see clearly. It is ARIMA 100011. Okay, what does that mean? So the first 3 digits is related to our AR term, the first one, so we chose AR1. So the seasonality, so it seemed like the trend was not captured. So the data is stationary, but we do have seasonality. So that's why I reflect on the second. So the D equal to 0, and then the MA term is equal to 0. But if we look at the seasonality sections, so the number of the seasonality in AR term is 0. So the number of the seasonality in the integrated term is 1. The number of seasonality in the MA term is 1 as well. Okay, so the best model the ForecastX picked is ARIMA 100011. Okay, so then to answer the question, what is suggested best model? So that's your ARIMA 100011, right? So after we estimate this, so this is my best model, what we're gonna do is we're gonna do the Lin-John box Q test, and then we will also, based on the diagram, the ACF, PACF for my residual, to see if the model ARIM 100011 is the best model to modeling this time series. Okay, so now next we're going to look at is, as I said, we will look at how can we carry on the statistic test. So the statistics, as remember, we picked 48 as my lags. Okay, so the 48 is the value for M. And so the statistic is 52.69. What we need to know is what is the critical value. So, okay, so as tradition, set up the 4 steps. So my null hypothesis is there is no autocorrelation in the data after applying the ARIMA model. Okay, so the H alternative will be there is autocorrelation in the data after applying ARIMA model. Okay, so the next is Q statistic. And then for that value, it is the one we calculate here, right? So now we're going to figure out the critical value. And then the formula we're using is chi-squared.inv.rt. Okay. And then let's, again, in the problem, it doesn't say the level of significance. Feel free to still use 0.1, or you can use 0.05. So 0.05 is more stricter statistic than 0.10. So let me just use 0.10. So now the degree of freedom. Again, the degree of freedom equal to the M minus P minus Q. So the M is the how many lag you use to calculate the Lin-John box statistics. As we know, we set up the Lin-John box lag to 48. The reason is because we believe the data has seasonality, and the occurrence of seasonality is every 12 months, right? So therefore, 12 times 4, it gives us 48. So the value for M equal to 48. And minus P, as you can see, the P value here is corresponding to the AR term. The number of AR term is equal to 1, right? But then minus the number of the MA term is 0. So that will give us degree of freedom. Okay, so it gives us the critical value, 59.77. As you can see, our Q statistic is smaller than 59.77, which is great. So that means we cannot reject HO. So there is no autocorrelation in the data after applying ARIMA 100 times 011 model. The model fits the data well. So this is the good outcome we are looking for. So now we know this, we can use this data to do the forecast, and the result should be reliable. Okay, so this is the question to address. How can we test the Lin-John box statistic, and whether that can prove this model, the best model we found using the ForecastX, is the best model we can use to forecasting this series. So the last part is finally plot the first 24 autocorrelation on the residual, so the autocorrelation for the residual. Again, so this is the second approach you can use to do the diagnostics. So in order to do that, what we need is our result, right? So we need to go up to find the column called the arrows. Okay, so this is the column of arrows. So you can see the first 12 observations, they are blank because we use the main reason here is blank because we set out the seasonality as 12. So that's therefore here is blank. So let's just starting from the one is not blank. Okay. So after I select the value that is not zero, not blank, non-zero, and then what I will do is I will just copy, and then creating a new column, and I will paste it. And then similarly, I don't want to miss my date as well, so I will copy and then paste it. And then so I can see here is the month, and on the right hand side here is the residual. Did I spell it wrong? Residuals. Okay, so after I do that, okay, let me zoom in a little bit. Okay, now I will select my two columns, and then I will click add in, and now I will select forecast. Okay, since I have the first column as the date, so you can see the data capture tab are set up very well. So it's columns, the label in the first row, perfect. And now I'm going to forecast, and make sure you choose box Jenkins. And after that, we are clicking analyze. Okay, by default, it only shows us 12 bars. So make sure we're increasing this to 24. So after you do that, you actually need to click OK, and then come back again, click analyze. So now you can see this is our ACF and the PACF diagram. Okay, so under the 24 length, we does see some spike right around 24s, but it's so far away from the present value. As we know, the model itself is weighted, so the further you go, the low weight you will give. So at this point, we don't see the spike in the closed term, and then we still think the model works well. So almost all the spike is within the 95% significant level. That means they are not statistically significantly different from zero. And so the reason the model didn't pick a ARIMA model with the more value on P and the Q is because we don't want overfitting the model. So therefore, we might still see some spike, but that is more like later terms instead of at the very beginning. Okay, so this is how we can finish a case, identify the best models. And so for this model, we are predicting the electricity usage, and we found the best model is ARIMA 100 with the seasonality adjustment as 011. Okay, so I hope you are enjoying this video, and I hopefully it helped for you to work on your homework. Bye.